If you like this video, please subscribe, like, and go to training.mammothinteractive.com where we have tons of more videos just like this. Coming up next in our project, we're going to implement collision handling, so we have to understand how collisions work in Unreal. In a game, objects can collide in different ways. It's not like the real world where if I collide with my door, I'm going to hit my head. In a game, you as the developer can determine what happens when objects collide. Can I go straight through the door as though I were invisible? Can I go straight through the door but still process the collision so I can still register that I went through the door so I'm not completely invisible? Should I bounce off the door with a great speed, or should I just hit the door and hit my head? Should I stop moving? Should the door explode? Should I die if I collide with the door? You can determine how collisions happen and what happens after a collision. And we can create these collision handlers in Unreal by attaching a collider to each object. So if you just have a model in the game, like a character or a house, by default, all of those objects will be invisible. If you want them to be processed in terms of collisions, so to have them be registered as objects with a body, then you have to attach a collider to the object. So although the object might be visible, it's invisible in terms of collisions unless you attach a collider onto the object. There are some rules for collisions to remember in Unreal. And don't worry if you don't remember all of them as a beginner, but you should be aware that there are rules when it comes to collision detection in Unreal. If you don't follow the rules, then you may get some unexpected results when it comes to handling collisions. You can adjust the collision properties of objects to adjust the collision itself. Rules include number 1, blocking will naturally occur between 2 or more actors set to collision block. So if you set the collision property to block, this means that we are blocking collisions between these two objects, so they will bounce off of each other. They will block the other from going through them. They might not necessarily bounce off with a great speed. It depends on what physics you set in the collision. The object could hit the wall and just stop. The player could hit another player and just stop. Or the player could hit another player and bounce to the different side of the room. As well, simulation generates hit events is a property that needs to be enabled to execute an event hit. So we have collision events, we also have overlap events and hit events. All three are similar, but you get more nuanced when you're dealing with complex collision handling and collisions at high speeds. So if you do want to generate a hit event, then you need to set simulation generates hit events to true if you're working with more advanced collisions. Another rule is setting actors to overlap for collision overlap will often look like they ignore each other. So if you set the collision property of an actor to collision overlap, this means objects can overlap with each other when they collide. Instead of blocking one another from moving, they'll overlap. So it will look like the actors can just go straight through each other. Without generate overlap events, then it is ignoring. If you set generate overlap events, it means the objects can go straight through each other, yes, but you can still register that they touched each other. If you set collision to ignore, this means that every object is completely invisible in terms of collisions, and we're not going to register any collisions that happen. But if you set collision to overlap and you allow generate overlap events, this means objects can go straight through. They can overlap each other if they touch, if they intersect, they can overlap. But we are going to register that. We're going to record that the overlap happened. This can be useful. For example, if I am collecting a coin in my game, I want to perhaps go through the coin And then maybe I want the coin to disappear and for my XP to increase. So I want to still go through the coin, but I want to also register that event. Same thing for going through a barrier. Maybe I want to allow a user to walk through walls, but I still want to register that they walked through the wall. Maybe they can walk through a wall, but every time they walk through the wall, they lose a bit of health. So they can do it, but at their own risk. For two or more objects, if one is set to overlap and the other is set to block, the overlap will occur but not the block. So you have to be careful about both of the objects in the collision. If both objects are set to overlap, then yeah, sure, they'll overlap. They'll go straight through each other. But if one is set to overlap and one is set to block, you might accidentally think and expect a block, but you'll get an overlap because you have to set both of them to block if you want the two objects to actually block each other. If one is set to overlap and the other is set to block for collisions in the collision properties, which we will see, the overlap will occur, not the block. So you have to be careful and be aware of these rules. Overlap events can be generated even if an object blocks another, especially if traveling at high speeds. So if your object is moving really fast, then you might get an overlap by accident. And even if you set both objects to have collision block, you might still get an overlap because the game might not be able to process the high speed overlap. In this case, you can use something else like hit for these high speeds. It is not recommended for an object to have both collision and overlap events. So that makes it more complicated to handle both collision and overlap on the same object. So it's recommended to pick one, collision or overlap or hit. It depends on the use case. For a beginner, you can stick with collision. And then as you have more complex collision types, you can start to implement overlap and hit. Another thing to note, if one object is set to ignore and the other is set to overlap, no overlap will happen. The objects will just ignore each other. So if you set collision to ignore on one object, you have to be aware that any object that touches that object will be ignored. No overlap events will be fired, so the objects will go straight through, but nothing will be recorded. So that is how collisions work in Unreal. We're going to get some experience with collisions coming up in the next lecture when we implement collisions in our project, so don't miss the next lecture. In this lecture, we're going to learn how to destroy a collectible or food upon player collision. Because currently if we collide with the food, we just hit it, but it doesn't disappear. So in this lecture, we're going to make the food disappear, as though the player collected it or as though they ate it. So for this, we are going to open our content drawer, and we have to go into our food blueprint class. So I am going to double click on the food blueprint class in order to open up its event graph, which remember you can move around by right clicking and dragging your mouse. We can remove some of these events that are created by default. So by default we have event begin play. An event allows you to perform some functionality when there is a certain event, such as begin play. This event will run when the play begins, so when the play button is pressed. You can click on a node to select it, and you can hit the delete key on your keyboard to delete it. We also have event actor begin overlap. This event will run its functionality when this actor overlaps another actor, for example, a player walking into a trigger. For events when objects have a blocking collision, for example, a player hitting a wall, see hit events. Note that components on both this and the other actor must have generate overlap events set to true. This is a property for being able to generate overlap events if you want to handle overlap. We're going to keep that blueprint event. We also have event tick. This is called every frame if ticking is enabled. Games typically run at 30 frames per second, so this event will run 30 times a second. This is useful for things like movement or checking if there's been an attack or a collision. But we can remove event tick as well by clicking on it and hitting delete. So we're just going to start with event actor begin overlap. Here we're going to perform some functionality when our actor, which is our food, collides with our player. So we can here pass in some kind of executable because this event target is an actor. So I'm going to drag from this white arrow, I'm going to drag my mouse off into the event graph and then let go. This will allow me to place a new node. So here I can search through a huge list of executable actions. For example, I'm going to cast to top-down character. This is part of the utilities group, specifically the casting group. Here, cast to BP top-down character, it's going to try to access the object as a blueprint class it may be an instance of. So you can double-click to or single-click to add this new node. These nodes are connected with this white line, which means that when this event occurs, we're going to continue down this flow through the white line. And we're going to go to the next step, which is to cast to blueprint top-down character. So this event target is actor, which means whatever was collided with, we're going to cast to a top-down character. Casting means you are forcing it to be of a certain type. We're casting because we only want to destroy the food if the top-down character collides with it. If anything else collides with our food, this will consider that the casting will fail. Because let's say we have a cube that collides with the food, well, then we cannot cast the food to a top-down character. So this is like a check to make sure that the top-down character is what collided with the food. If that is true, then we can destroy the food. If the cast failed, however, then we will not destroy the food. So we will only destroy the food if the actual collision was between the food and the top-down character. So then, here we have our cast. We can drag, again, from its white arrow on the right-hand side. We can drag another line to place a new node. And this is going to continue the flow. So the flow always goes from left to right through these white arrows. So here, we're going to drag that white node off again, and we're going to search for another node we will call destroy actor. So this is part of the actor group. This will destroy the actor. What actor are we destroying? Well, we're destroying self, which means the current blueprint, and that is food. So we're going to destroy the food. So to begin, as soon as the food collides with an actor, we're going to check if that actor was a top-down character. If so, we're going to destroy the food. We also have these other little options on the sides of our nodes. So we have other actor. Here we can make a reference to another actor. So this will check an event when this actor overlaps another actor. So we could check which one. The cast has an object, which is going to be what it takes in. So in this case, we're taking in the other actor, and we're casting it to a top-down character. This will return our actor as a top-down character. So these circular buttons or options, they refer to values. So the event actor begin overlap will return this other actor that was part of the collision. This object refers to that other actor, which it will take in from the event. This blue circle as top-down character refers to the actor, the same one that has now been cast to a top-down character. So if you ever see a circle, it refers to some value. If you see a triangle or an arrow, This refers to flow of execution. So for example, we're starting at the event, and then we're flowing to the cast, then we're flowing to destroying the actor. And we could flow to something else if we wanted to. So we are using an event as well as a cast and then a function to destroy the actor. So the function is a type of executable. So a job of a function is to perform a specific task. For example, in this case, the job of this function is to destroy an actor. Which actor? Well, whatever actor is on the left-hand side here. In this case, it is the self. So we are destroying the food, because when we talk about self, we are referring to the current blueprint that we are in, our self. So this function will do a task. In this case, it will destroy an actor. This event will run when a certain event occurs. In this case, when the actor overlaps another actor. Actor begin overlap. We can refer to that other actor if we want to, or we can do nothing with it. We can then specify what we want to happen upon that event. In this case, we want to cast that other actor to a top-down character, because this event will return the other actor, because it's showing up here on the list on the right-hand side. So this event will store this other actor, and we can use it in the next node, because the next node, if we're casting, we're taking in an object, and by default, the object will be sent to this second node. So this other actor is returned by the first node. It's stored by this first node, and it's sent through this white line to the second node. It goes from the right-hand side of the first node to the left-hand side of the second node. Then we perform the task of the cast, which is taking this object and forcing it to the top-down character type. This is only possible if the object actually is a top-down character. If the object is something else, like a pyramid, the cast will fail. If the cast fails, well, in this case we do nothing, but we could do something, but in this case we're just doing nothing. If the cast succeeds, then we can continue along the next white line here, the executable connection line, and do our next course of action, which is to destroy an actor. What actor? Well, we're destroying whatever actor is passed into the input here on the left-hand side, which is self. Self meaning the current blueprint. The cast returns the object that it took in. So the cast takes in an object on the left-hand side, and it returns that same object, but this time the object is cast to a top-down character. So we have the object, but it's now as a blueprint top-down character. So we can refer to that object and use it if we wanted to. Or in this case, we just do nothing with it. We just go to the next order of execution. So on the left-hand side of a node is the input, what the node takes in. On the right-hand side of a node is what it spits out, what it returns or stores. So the event, it returns an other actor. The cast, it takes in an object, which is that other actor, because these two are connected, therefore we're passing the actor from one node to the next. This cast will return the top-down character. Because remember, values are represented with circles, whereas execution statements are represented with triangles. So this cast takes in the object, and it returns the same object as a blueprint top-down character. Then that is sent to the next node, the next order of business, which we decide to destroy an actor. But what actor are we destroying? Well, we are destroying whatever actor we pass to the input of the function. In this case, we're passing in self, which is the food. But if we wanted to destroy the player, we could send the player as the target by making a connection between these two. If we make this connection, the target is no longer the food. The target is now the top-down character. if we want to break this connection, we can right click and we can break the link to destroy actor. Then we go back to the default. So this target is what will actually be destroyed. And we can test this out by saving and compiling. If you get an error message that says that an object is undetermined, then we have to connect something to cast to blueprint top-down character to imply a specific type. So we're going to send this other actor to that cast. Then I'm going to save and compile again, and now our compilation is successful. So if you get error messages pop up in your compiler results, then you should read them and fix whatever the issue is. So in our case, the issue was we had to make a connection between the other actor and the object here. So by default, the event did not send the other actor to the cast. We had to send it ourselves. So these arrow lines, they refer to order of execution. If you want to pass a value along, you have to make the connection via the circular lines. In this case, taking an actor, and we are sending the actor to be cast. So this cast, it wants to know in its input, what do you want to actually cast to a character? Well, we want to cast the actor part of the event of the actor begin overlap, which means the actor that collided with this food, the other actor that was part of the collision, other than ourselves, because we are currently food. So now we can save and compile again to check our work. Then we can close the blueprint editor. We can run our game now and we can inspect our results. So you can take a look now. You can see things may appear different from what we expect. So we're not seeing the food being destroyed. We can check our output log to see what is occurring. And let's discuss why we're not seeing the food being destroyed. Because currently, if we collide with the food should be destroyed. Well, the reason the food is not being destroyed is because we have to add a collider to it to process collisions. So for that, I'm going to open my food again, but this time I'm going to go into a different window. So here I am back at my food. If you want to open up your actual visual, you can click on Viewport. And if you want to see the components that make up this visual for the food, you can go to Window, Load Layout, and select the default editor layout. This will bring back the default layout for the blueprint editor. So now you can see your components. So we can go to our viewport as well. All right, so in our components, we have a default scene root, as well as our sphere and our point light. I want to add collision onto my sphere. So I need to add a collider. That way we can actually process collisions. So I'm going to add another component and look for a sphere collision component. This is a sphere generally used for simple collision. So we'll add that and we can call it our sphere collider. So now we can double click on the sphere collider to inspect it, right? And it's been added onto our sphere. Under details, we can change the shape of our sphere collider by increasing the sphere radius so that it's a bit bigger. All right, so here now we've added a collider to our food so we can handle collisions. So here I have my collider and it has a collision property. We want to make sure that we have several properties set here. Generate overlap events to true. That way we can actually handle when this food overlaps with another actor. Our collision presets can be overlap all dynamic, but there are other options as well. For example, if you don't want collision, you can set no collision. Overlap all dynamic means that we are going to allow overlapping with all of our other actors. Right, so we can save and compile and then close this blueprint and we can run our game again. This time, look at that. I ran into a food and it disappeared. I can try it again and it disappears. So because we added a collider, this means collisions can actually be processed. So you have to, yes, build out the blueprint event graph, but you also have to add a collider to your food items. And look at that, we ate all of our food, it's all gone. We can add more food objects into the game just by dragging them into our game here. So you can reuse as many food items as you'd like. You can put them around the game. You can hide them behind objects. You can make a maze. You can set a time limit so that users only have a certain amount of time to find all the food. You can make the food hard to reach in different areas. You can make the food disguised. You can make the food hidden behind an enemy. So there's lots of opportunities for expanding this game beyond this starting point that we have currently. All right, so we added more food. We can run the game again. And look at that. Every time I collide with the food, it disappears. And so it acts as though we ate it or that we collected it. So that is how you can build out a blueprint with visual scripting to process collisions. So we coded, but with visual scripting. All of this functionality like events, functions, casting, those are all from programming, but we just did it visually instead of with code. Then we also learned that we had to add a collider to the actual object itself. Otherwise, the collisions could not be processed. Join me coming up in our next lecture. We're going to continue looking at how to build our game with blueprints. If you liked this video, then go to training.mammoethinteractive.com. We have tons more content on blockchain, web development, machine learning, and much more. We also have a membership for just $19 a month where you can get access to our 372 course bundle and counting.